Today in pre-cal we talked about 4 main topics, and we used this kind of foldable to do that. The first one was angles, degrees, and radians. And most of this should be reviewed from the notes we did on the pink paper back on Thursday of last week. So let's just go over that. Starting with the bottom of this tab, we drew a coordinate plane, and we reviewed the quadrants 1, 2, 3, and 4. We reviewed that this is 0 degrees, 90, 180, and 270. A full turn of the circle would be 360. We reviewed what those would be in radians. So we started with 0. And then this was pi. We know that to be about 3.14. We said that this was 2 pi, which is about 6.28. If we cut pi in half, we had pi over 2, which was about 1.57. And if we did halfway between pi and 2 pi, we would get 3 pi over 2, which is about 4.7. And those are values that we would need to know. Finally, when we are trying to convert from radians to degrees or degrees to radians, we will use these pieces. That pi over 180 will help us go from radians to degrees. And to go from degrees to radians, we're going to use 180 over pi. And actually, I'm actually pretty sure I have those flipped. So let me change that around. This is from radians to degrees, because those radians would cancel. And this one is from degrees to radians. So that's just one minor little change. Okay, we're going to look at 3 examples here. The first one is that we want to find 11 pi over 6. So we're going to draw our little coordinate plane. We're going to remember that if we had to find 11 pi over, I'm sorry, not over 6, we did over 3 in class. I don't want to confuse you from your friend's notes, so let me do that again. 3, if we divide our quadrants into 3, just the top half into 3 pieces, we did that. I'm just going to do a little dotted line. Remember, we scratched out the middle so that there are 3 equal pi pieces, 1, 2, 3 on the top and 3 on the bottom. And I'm going to count around 11 times with 0 being my initial side. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I went around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. 11 pieces of pi, and it ends there. Notice my circle coordinates with that, and this would be my angle. Okay, let's do another one. What if I wanted to find negative 2 pi over 3? Again, I'm going to draw my coordinate plane. I'm going to cut my pieces of pi into 3 for the top and 3 for the bottom, since that's my bottom number. I'm going to start with my initial side being 0, and I'm going to go backwards 1, 2, pi over 3, which makes this my terminal side, and this is my angle. Remember, I'm going in the clockwise direction because I'm trying to find negative 2 pi over 3. The last thing I want to show you in this section is how to convert negative 2 pi over 3 to degrees. And if I want to do that from radians to degrees, I'm going to do this 180 over pi. So I'm going to do negative 2 pi over 3 times 180 over pi. My pi's will cancel. If I do negative 2 times 180, I get negative 360 over 3 times 1 is 3. And if I divide that, I get negative 120 degrees. Okay, now I've done an example of each kind that I think you might have on your assignment and things that are relevant to what we'll be doing in the future. So that's it for the first tab. I'm going to close that one up, and let's move on to the next one, which is complementary angles. Okay, if we're looking at complementary angles, the definition for that would be any 2 angles that add up to 90 degrees or pi over 2 radians. You learned about this when you were in geometry, so I'm not going to focus a lot on the 90 degrees. I'm going to focus more on the pi over 2 radians. Let's look at 2 examples of that on this top half. Example number 1. If I want to find the complement of pi over 6. The first thing I'm going to do is draw a little sketch of where pi over 6 is, and that would be here. I know that because I divide my top half into 6, so halfway through would be 3 pi over 6, so 1 pi would be about here. And I want to know what this angle is, this in-between angle that makes pi over 6 plus this piece equal pi over 2, or a full 90 degrees. To do that, I'm going to do pi over 2, because that was 90 degrees in radians, minus pi over 6. Now, to subtract fractions, I have to have common denominator, which will be 6. To make 2 go into 6 3 times, and so I have 3 pi over 6, which is equivalent to pi over 2. 3 pi over 6 minus 1 pi over 6 is the same as 2 pi over 6, which is the same as pi over 3 when I reduce it. So pi over 3 is the complement of pi over 6. Let's try another example, number 2. I want you to find the complement of 3 pi over 4. Let's draw a sketch. If I divided my top into 4 pieces, it'd look about like this. 3 pi over 4 would be right here. And so as you can see, that's more than 90 degrees. Anything that's more than 90 degrees, the answer is no complement, because there isn't any positive angle I can add to it to make it equal 90. And I don't want negatives when I'm talking about the complement or the supplement. Which brings me to our next tab, supplementary angles. Supplementary angles are two angles that add to get 180 degrees or pi radians. That should make sense to you because 180 degrees is the same as saying pi radians. Let's look at an example of how I would do that. This is the example 1 and only on this tab. I want you to find the supplement of 3 pi over 4. If we sketch that, we know it's about here because we just talked about that one in the previous example on complementary angles. So I want to know what this distance is, what this angle is right here in between to make it all add up to pi. To do that, I'm going to do pi minus 3 pi over 4 because that will give me the in-between piece. I need to get a common denominator, so I'm going to do 4 pi over 4 minus 3 pi over 4, which equals pi over 4, which is the supplement of 3 pi over 4. The last tab we need to look at today is how to find coterminal angles. To find coterminal angles, I first need to know what they are, so let's get a definition for that. And the definition is if two angles have the same initial and terminal sides, they are coterminal. Okay, so that's the definition for coterminal, that they have the same initial and terminal sides. Also, there are infinitely many coterminal angles. There are infinitely many coterminal angles for any given angle. And if I write that mathematically, that's saying any angle theta plus or minus 2 pi n will give me a coterminal angle. Now that n stands for the number of loops that we do around the circle. And the best way I can explain this to you is say we start at 30 degrees and we add 360, we go around one time, then we're talking about 390 degrees, but we're in the same spot. We can call those two the same thing because they are coterminal. They're both 30 and 390. Just like I could turn one back way of the circle from 30 and subtract 360 degrees, and that would end me up at negative 330 degrees, which is another coterminal angle to 30. Let's look at an example like this. Example number 1. I want you to find a positive and a negative coterminal angle 4 pi over 6. Okay, again, we've practiced that several times today. That angle is about here. And I want to know what its coterminal angles are, one positive and one negative. So I'm going to do pi over 6 minus 2 pi and pi over 6 plus 2 pi, because one of those is subtracting a full turn of the circle and the other one is adding it. To be able to do that, I have to have a common denominator. So I'm going to do minus 12 pi over 6 and likewise plus 12 pi over 6, because 12 pi over 6 reduces to 2 pi, just is getting me a common denominator. For the negative, I have 1 minus 12, which is negative 11 pi over 6, and it did yield a negative answer, so that one will satisfy. And positive 1 pi plus positive 12 pi is 13 pi over 6, which is one positive coterminal angle. I want one of each. If I didn't get a positive or negative, I would keep adding intervals of 2 pi. So if I did 2 rounds, I'd be adding 4 pi. 3 rounds would be adding 6 pi, on and on and on, until I got the answers for this. Your assignment will be posted on the Facebook page and was in class, but it's A11, which is page 290, 17 to 24.